As I explained in the previous presentation, there are two types of statistical analysis: descriptive statistics and inferential statistics. Descriptive statistics summarize information that is contained in your sample, whereas inferential statistics draw conclusions about your population from what you observed from your sample. In this presentation, I will introduce what inferential statistics is. Then I will explain multivariate statistics, particularly different types of regression models. The goal here is to understand what those statistical analysis tries to accomplish and how you can interpret the estimated outcomes as you read others' study. Basically, inferential statistic tells us if our observations about the sample can be generalized to the population. The observation can be about the nature of a particular variable or relationships between two variables or multiple variables. So, from the discussion of sampling, we know that we cannot directly observe the whole population, and therefore we will get a subset of it, which we call sample. Apparently, despite our efforts to get a sample that is representative of the population, it is not guaranteed that what we observe from our sample is exactly the same with what we would see from the population. Then, to generalize our findings based on the sample to population, we have to provide some statistical evidence to show that what we observe from our sample is not way different than what we would observe from the population. Basically, the statistical calculation will help us obtaining the probability that what we observed in the sample does not reflect what exists in the population and is happened only by chance or due to an error. This probability is referred as the p-value. The p-value calculated from your sample is then compared to a standard that will determine if your outcome based on the sample is only by chance or an error. Often in education and social science research, that level is at 5% or 0.05 level and 1% or 0.01 level. These criteria mean that the chances of your sample findings appear due to the error is 5% or 1%. So if you flip it, then you can say that for 95% or 99% of the time, you're sure that what you observe from your sample is similar to what you would observe from the population. If your p-value is smaller than those standards, then your estimated results are statistically significant. What it means is that we can be confident that the estimated statistics from the sample is not observed or produced by chance. In studies, the statistical significance is often indicated with symbols such as asterisks. Now, let's move on to multivariate statistics, which often employs inferential statistics. Multivariate statistics examine relationships among multiple variables simultaneously. In particular, regression models estimate relationships between one outcome variable and multiple explanatory or independent variables. Basically, you can use regressions to predict how values in the outcome variable change as values in explanatory variables change. Here are some examples for research questions that you can employ a regression analysis. What factors are associated with the likelihood that a student will graduate from ASU in 4 years? Basically, this question is looking at the changes in graduation outcomes as combination of various factors change. The second example is what type of academic and extracurricular activities predict students' GPA at ASU? Again, in this question, the researcher tries to analyze the relationship between students' GPA and various academic and extracurricular activities altogether. There are various regression models, and the choice of a particular model depends on the type of the outcome or dependent variable. When your outcome variable is a ratio or interval variable, then you will employ a linear regression, which is the most common regression model. On the other hand, if your outcome variable is a binary variable, meaning that it has only two categories, such as yes or no, then you will use a logistic regression. Finally, if your outcome variable is a categorical variable with three or more categories, then you will employ a multinomial regression. Let's look at an example of linear regression. A researcher is investigating a research question that is, does receiving an orientation on college rules for drinking influence the number of drinks students consume? To answer this research question, the researcher needs to estimate the relationship between number of drinks and the existence of orientation, as well as other characteristics of students such as gender, race, age, and participation in fraternity or sorority. And the table contains the estimated outcomes. Remember that regression analysis is an inferential statistic. Therefore, when you interpret any regression outcomes, you will need to first look at if there is any independent variables that are statistically significant. For example, we will see that the variable male is found to be a significant predictor for the number of drink consumed at the 0.05 of confidence level, indicated by the star signs, right? Also significant is the participation in fraternity and sorority. Once you identify significant variables, then look at the estimated numbers on the column beta. The beta is called regression coefficient. This number basically explains how much outcome changes as the independent variable changes. For example, being a male, so compared to a female, increases the number of drinks by about 16. Also, participation in fraternity or sorority increases the number of drinks by about 14. Meanwhile, being an African American student has a negative relationship with the number of drinks consumed because the beta or regression coefficient has a negative sign. Are these findings similar to what you would expect? Yes or no? You will need to discuss this in your writing if it was your own research project. Meanwhile, you use logistic regression if your outcome variable is binary. What if the researcher now looks at whether or not having an orientation would have an impact on students' binge drinking? Now, the outcome variable is whether students binge or not binge on drinking. For logistic regression, the regression coefficient is reported in odd ratios. Basically, if your regression coefficient is equal to or bigger than 1, that means the odds of binge drinking is increasing. Meanwhile, if the estimated odd ratio is smaller than 1, then the chances of binge drinking is getting lower. Again, we start with looking at the significance. We see that being part of a fraternity or sorority has a significant relationship with the student's chances of binge drinking. Now we look at the number. In this case, the odd ratio is 2.35, which is bigger than 1. So the result suggests that being in fraternity increases a student's odds of binge drinking. Meanwhile, we see that Asian and Pacific Islanders is also a significant predictor for binge drinking. Now, if you look at the odd ratios for that variable, it is 0.25, which is smaller than 1. So we can conclude that Asian students tend to drink less than the omitted category of the race variable, which is white students. To summarize, when you read any regression analysis results, first look for the variables that are statistically significant. What does that tell you? Yes, the statistical significance indicates that the relationship between the variables you observe from your sample will be likely to be found from your population. Then, for the variables that indicated statistical significance, watch for the estimated coefficients in terms of the direction of the relationship, i.e. positive or negative signs. Also, the absolute value of the coefficient will tell you how large the relationship between the dependent and independent variable is. Finally, again, be careful not to make a strong causal claim. What we observe from the regression analysis is correlation, and we do not know if there is no other factor that influence on the relationship between the independent variable and dependent variable. It is safer to use verbs such as associated, related, correlated, tend to, and probably impact or influence, rather than using terms such as affect, cause, or make. So how are regression models employed by actual studies? Perna 2005 examined a research question that is, what economic benefits did 1992 high school graduates who attained various levels of education realize by 2000? Basically, she tried to predict the income level based on the level of education, as well as other demographic and academic factors such as gender, race, socioeconomic status, and test score. From a linear regression analysis, she found that attaining a bachelor's degree has a positive association with one's income level 8 years after high school graduation. Meanwhile, gender was another factor that was statistically significant to predict one's income level. The regression coefficient was negative, indicating that female tend to have a lower level of income than male. Ku and his colleagues analyzed a research question that is, does engagement during the first year of college have a significant impact on chances of returning for a second year of college, net of the effects of student background, pre-college experiences, prior academic achievement, and other first-year experiences. Basically, they estimated the relationship between various engagement and first to second year retention, considering all other demographic and academic backgrounds. The outcome variable then is binary because it is whether or not a student returns for a second year. Thus, the researchers conducted a logistic regression analysis. As you see in the table, they found that hours spent on co-curricular activities and participation in educationally purposeful activities are significant factors that predict students' retention. The odds ratios for each of those variables was bigger than 1. Thus, the conclusion can be that engagement in co-curricular activities and educationally purposeful activities increase the probability or chances of a student returning for a second year of college. Okay, so in the last two presentations, we reviewed different statistical analyses that serve different purposes. The decision of what statistics to estimate and report depends on the number of variables and types of the variables involved. Again, those pertain to your research question. In the class, as usual, we will have a short question and answer section on the online content. If you have any questions, bring them to the class. Then we will continue with an activity using a research study with a focus on the data analysis and research sections. We will also allocate some time to continue working on your research design, including the statistical analysis you might need to conduct and different reporting methods that you will employ.